Hi everyone, so I wanted to go over solving a quadratic equation using the quadratic formula when the solutions are complex or imaginary. So remember when we're solving a quadratic is our parabola. We're looking for the solutions or the zeros. So in this case, where it touches the x-axis, this would have two solutions. So if my solutions do happen to be imaginary, remember it would look something like this, right? Where it doesn't touch the axis at all. So we don't see any zeros or solutions. But since we're expecting two, since we have degree two, that means our two solutions would be imaginary. So in order to solve, let's remember we always want it in our equation in standard form equal to zero. So A, B, and C are the coefficients in front of each of those respective variables. And our quadratic formula is opposite B plus or minus B squared minus 4AC under the radical all over 2A. Okay, so if I want to solve this, I know my A term is going to be 1. My B term is a 4. And my C term is a 5. Okay, so that's my A, B, and C. So if I go ahead and plug this into my formula, I do opposite B. So if my B is a 4, a positive 4, we're going to do a negative 4 plus or minus. Okay, I want to square the B, so B squared. So that's the 4 squared minus 4. And then this is times A times C. So there's all multiplication here. So I want to do times that A is 1 times the C is 5. Remember, I always like using parentheses inside, even if, especially when this is negative, I need parentheses. But even without, I always like parentheses when I substitute. So 2 times A, I'm also going to use parentheses to substitute in that 1 for the A. Okay, so this should be my initial substitution. So to simplify things, we always do inside the radical first. So 4 squared, 4 times 4 is 16, minus, and then multiplication before subtraction. So I'll leave the subtraction there. We're going to do 4 times 1 times 5. So that's basically 4 times 5, which is 20. Okay, and then all over 2 times 1 is just 2. Okay, so if I simplify inside the radical, you should notice 16 minus 20, we do have a negative number. So remember, if I have a negative under the radical, by definition, the square root of negative 1 is I. So negatives come out as the imaginary unit I. So if I take the negative out, there's going to be an I on the outside of the radical. And we also have a 4 on the inside, which is a perfect square. So the square root of 4 is 2. So that also gets to come out of jail. So both I and 2 are going to get to come out um, of jail, basically. So if I look at what I have here, the radical does go away. Okay, remember this entire thing is divided by 2. So I want to divide both the negative 4 and the 2I by 2. So I basically want to make sure both of those get divided by 2. So I can split this up. And remember, we always like in our complex, we always like A plus BI. That's our standard form. So I want my real part and then my I part, my imaginary part second. So half of negative 4 is negative 2, plus or minus. The 2 divided by 2 is 1I, and I don't have to put the invisible 1 in front. So my solutions here are negative 2 plus I and negative 2 minus I. So two complex solutions here. Um, and we'll go over ones where not everything gets to come out of the radical. You still want to split up whatever the bottom is to both here and here. But that'll be my answer for that first one. So let's look at the second one. So we have x squared minus 6x equals negative 12. So the first thing I notice is it's not equal to 0. So my first thing I want to do is I want to bring everything to one side. So I'm going to add 12 here. So everything's on the left. So we have x squared minus 6x plus 12. And then 12 minus 12 is 0. So that does go away. Okay, so if I look at my quadratic equation, it looks like we have an invisible 1 here. So my A term is 1, my B term is a negative 6, and my constant is a 12. So we have A, B, and C. So let's go ahead and plug that into our quadratic formula. Let me just write it first to remind ourselves. Okay, so x equals, so opposite b, so my b is negative 6 here, so I'm going to do a positive 6 plus or minus. That b of negative 6 needs to be squared, so I'll definitely need parentheses there. Square the entire b term minus 4 times A is 1, C is a 12. Okay, and that's all going to be over 2 times, once again, A is 1. Okay, so that's my initial substitution if I put A, B, and C in. So if I simplify inside the radical, -6 times -6 is a positive 36. And then I want to do 4 times 8 times C. And if one of these was negative, this negative times a negative would become positive. But since there's only this one minus here, I'll leave it there. We're going to multiply 4 times, that's 1 is 4, so 4 times 12 should be 48. And 2 times 1 is just 2. So inside the radical, we're going to have 36 minus 48, which is going to be a -12. So once again, you'll notice we have a negative inside the radical. So we have a smaller minus a bigger number. So it's going to be a -12. Okay, so if I think about how to break up a -12, well, first off, I could take the negative out as I. So I'm going to have an I on the outside. So a -1 will come out as I. But we also want to break up 12. So I could take the negative out. And 12, I want to, well, 6 times 2, yes, but I want a perfect square factor. So it's also 4 times 3. Okay, so this is a perfect square, so that gets to come out of jail. So square root of 4 is 2. So along with this I here, a 2 will also come out of jail. So we're going to have a 2i on the outside, and then this radical 3 is going to be stuck inside. So the negative I could take out and the 4 I could take out. So that'll simplify to 2 times I times radical 3. So 12 break up to 4 times 3 to simplify that. And remember, this entire thing is over 2. So I want to make sure this gets divided by 2 and this gets divided by 2. So I'm going to make sure both of these gets divided by 2. Okay, so to finish this up, 6 divided by 2 is 3. And then here, remember the 3 is inside the radical, so that's stuck in jail. So that doesn't get to, we can't do anything with that. So that's going to stay a 3 no matter what. But on the outside, we can simplify 2 divided by 2 is 1. So we have 1i radical 3. So 1i radical 3, you could write the invisible 1 in front. So this will be my final answer. So my two solutions are 3 plus I radical 3 and 3 minus I radical 3. Okay, so that's generally how we want to simplify. But one thing I also notice here, I want a plus bi. So notice the I is in front. I want the number in front of I. So I'm just going to switch this around. You could do this in another step. I'm going to put the radical 3 first, and then the I. Make sure the I is not inside the radical, so make sure that's separate. But this will be a plus bi form, so that'll be my final answer. So to have it in standard form, I'll do that. But generally you do want numbers before the radicals, so either one would be fine. But this is more this is standard form, so this will be my final answer. All right, let's look at one final one. So once again, it's not equal to 0, so I'm going to bring 4x over. So let's get everything to this side first, just to get practice getting it into standard form. So I want the ax squared term first, then the 4x, and then we just have a plus 1 there. So ax squared plus bx plus c. So that's the order I want. Okay, so you should be able to notice your a, b, and c here. Okay, so let's go ahead and put that into our quadratic formula. So I want opposite b. So my b here is -4. So I want a positive 4 plus or minus. We need to square that b. So negative b squared minus 4a is 5 this time, not 1. So that's going to change it. And then c is 1. Okay, so all over 2. Once again, a is 5. So 2 times 5. Okay, so let's go ahead and simplify this radical. So -4 times -4 is a positive 16. And then once again, we minus once again, if we had another negative like over here, a negative times negative will make this a plus. So be careful with your sign. But if I do 4 times 5, that'll be 20. Times 1 is just 20. So this will just be a 20, since it's just a positive 1. If it was a -1, I would just make it plus 20 here. But since it is minus 20, it is going to be a negative number. So it looks like we're going to have this will just be 10. 2 times 5 is 10. So it looks like we're going to have a -4 inside there. So 16 minus 20 is -4. Okay, so that's how I'll simplify inside the radical. Um, so the square root of -4 is going to be, well, the square root of 4 is 2, and then the negative comes out as an I. So we're going to have an I on the outside along with that 2. Okay, and the entire thing is being divided by 10, so I'm going to make sure both of these gets divided by 10. Okay, so if I do 4 over 10, I can simplify that. So 4 over 10. So on the calculator, before I click enter, I could click on math, and fraction is the first option. Or they're both even, so I can just divide them both by 2. So half of 4 is 2, half of 10 is 5. So this should be 2 over 5, but you have your calculator for that as well. So you're going to 2 over 5 plus or minus. And remember, I do want a plus bi, so I'm going to keep this number in front of the I. So 2 over 10, once again, if I split them both in half, half of 2 is 1, half of 10 is 5, or type in the calculator. So a plus bi. So this, and I'll bring that x equals back. Those are my x-intercepts. So we won't see it on the graph once again, but these are going to be my two solutions, 2/5 plus 1/5 I and 2/5 minus 1/5 I. So that's generally how you would want to solve it. And just to clarify, the stuff we got under the radical wasn't too bad. Most of it got to come out. But if I did have something like um, a weird number under the radical that I can't simplify, just like 31 or whatever, um, you would still want to take out the I to simplify it. So for something like this, you could take out the I and just leave the number inside. So sometimes the number won't get to come out, but you still want to take out the imaginary unit. And then once again, um, I would split up this two. Once again, this is your, if you leave it like this, most time that's the correct answer. You would be fine with that answer. But if you do split up the two and get it into standard form, 8 divided by 2 would be 4. And then remember, I want BI, so I want to put the I on the outside. So radical 31 over 2, we can't do anything with. So I'll just leave that. I would just leave that how it is. But if I had something that looks like this is how I want to get it into A plus BI form. Because I think sometimes putting the A, B, and C in isn't that hard. That's not where the trouble comes in. The trouble comes in when it comes to simplifying it or breaking it up. So just to go over something like this, sometimes you might have a nice number or part of it comes out. Sometimes you might not. But either way, you do want to take out the I and then divide. Remember, only the number outside gets divided by 2. So even if this was like 32, well, then you would, uh, or let's say like this was 34. Um, so something you can't split up. You can't make that like 17. It's inside jail, so you can't do anything with that. So this is how you would leave it if that was the case. But I would look up to break up the 34 to take a perfect square out if possible. So just to quickly, if that comes up, just to go over how to simplify that. So what I want you to do is I want you to try these four. So you can pause the video, write these down, do one at a time. So see if you get the answers in simplest A plus BI form, ideally, to these four problems on your own. All right, thank you for watching.